Howdy folks, it's Mr. Ryan, and we're moving on now to lesson 6.2. Remember, this is the 9th grade math class, the summer session version, okay? So in the last video, 6.1, we looked at data sets, and we looked at how to use the sigma notation for identifying the mean of a data set. Now, one of the reasons we looked at the sigma notation is because in this lesson, we're going to learn how to identify what's called the variance of a data set and the standard deviation of a data set. These are also going to use the sigma notation. So now it's going to be a little more complicated. You in your mind, you already knew how to do a mean, so you didn't need the sigma notation necessarily. But none of you knows how to do the variance probably without the sigma notation. And so now we're going to have to use the sigma notation. There's no shortcut in order to identify the variance, okay? Now, the good news is once we know the variance, we can then identify the standard deviation. It's very simple. This symbol right here, this says it is the lowercase letter sigma. So this sigma that we saw in lesson 6.1, the one that looked like this, that's uppercase sigma in Greek. And then this, it's like a circle, and then you put like a stem on the top, okay? That's called sigma, but it's lowercase sigma. And when we put a square on it, we call it sigma squared. Okay, that's sigma squared. Okay, and in mathematics or in statistics, sigma squared represents the variance of a data set. And then the standard deviation of a data set is just called sigma, okay, or the population standard deviation. It's called sigma. Now, interestingly, it's really easy to calculate the standard deviation. Calculating the standard deviation requires you to know the variance, and it's just the square root of the variance, the square root of sigma squared. And so, for example, if I told you that sigma squared of a data set was 36, then we could say that the sigma, the standard deviation, is simply the square root of 36, which is 6. Okay. If I told you that the variance of a data set was 14.3674, then the sigma, the standard deviation, would simply be the square root of 14.3674, which we could go then find in the NumWorks calculator, and we could just type in, let's move this out of the way for a second. We could type in the square root of 14.3674 and execute, and we would get 3.79, what is that, 04, 3.7904. Okay, so this would be 3.7904. And so what I'm telling you here is that in order to identify the standard deviation of a data set, you first must identify the variance of the data set. And after you've identified the variance of the data set, all you have to do then is just simply take the square root of whatever the variance is. That gives you your standard deviation of that data set. Okay? All right, so great. So here's what we're going to do. We're going to do a few examples, 4 examples actually, where what we're going to do is we are going to first identify the variance of the data set, and then we're going to identify the standard deviation by simply taking the square root of the variance, okay? Now, unfortunately, the variance has a kind of an ugly and complicated formula, okay? So let me go ahead and give you the formula. The formula for the variance of a data set goes like this, okay? It's going to be, where is it? There it is. So we have to do a sum, a sigma sum, and just like the mean, it's going to go from 1 up to n. And in this case, we're starting with data set x sub I, and what is the n of this data set? Well, we have 1, 2, 3, 4, 5 elements or 5 numbers in this data set, so n is equal to 5. Okay, so for this formula, when we do this sum, it'll be I equals 1 up to 5, okay? But we're just writing the formula right now. Now, here's the hard part, okay? What are we going to take the sum of? Okay, so we have to take the sum of not just each individual element. We're going to take each individual element, each x sub I, so that means x1, x2, x3, x4, x5, and what we're going to do is we're going to subtract away the mean from that number, and that means that we have to find the mean first. So the first thing we're going to need to do to be able to identify the variance is we first have to know the mean. So before we even start doing this formula, the first thing we'll have to do is do what we did in lesson 6.1, which is find the mean of the data set, okay? And then what we'll do is we'll take each individual element, subtract the mean from that element, and then we're either going to have a positive number or a negative number. And then what we're going to do is we're going to square that number. And then after we do that to every single element, we have to do this whole thing, the subtracting and the squaring to every element. Then we'll have 5 numbers that we can then add up. And once we've added up those 5 numbers, the last thing we're going to do is we're going to divide that whole sum by n, okay? All right, so write this formula down. You're going to need this formula. And so to identify the variance of this data set right here, the first thing we're going to need is the mean. And to find the mean, we need to do the sum from 1 up to 5 of all the x sub i's divided by 5, okay? And so we have to add up all 5 terms. So we're going to do 14 plus 17 plus 12 plus 14 plus 15. And we're going to divide that whole thing by 5, okay? And so we can use a calculator, but I'm going to try and do this in my head. 14 plus 17, that's 31. 31 plus 12 is 43. 43 plus 14 is 57. Plus 15 is 72. And so what we have here is 72 divided by 5, okay? Now I am going to use a calculator for 72 divided by 5. So 72, let's move this out of the way, divided by 5 equals 14.4, okay? All right, so we know that the mean is going to be 14.4. And so what that means is now when we do this, okay, our formula is going to be xi minus 14.4, and then whatever number we get here, we're going to square it, okay? So to identify the variance, sigma squared, okay, what we're going to do is we're going to do a sum from 1 up to 5 of each element, x sub I, minus 14.4, because that's what the mean is, then square it, okay? Then we're going to divide that whole sum by 5, because there are 5 elements, okay? All right, so what we need is, for each I, which is 1, 2, 3, 4, 5, we need to do this binomial that then becomes squared. So we need to do x1 minus 14.4 and then square it, okay? All right, well, let's go ahead and do that over here. What is x1? It's 14 minus 14.4 and then square it, okay? Well, that's going to be 14 minus 14.4 is negative 0.4 squared, and we can do that in the calculator. So here we're going to do, let's move, I'm just going to move the calculator instead of my head. We're going to do parenthesis, negative 0.4, close parenthesis, then we're going to square it, and it's 0.16, okay? So, so this is going to be 0.16. Okay, so what we're going to have here is 0.16 is our first number. Then we're going to add that to another number. Okay, All right, well, what's our next number going to be? Well, now we're going to put in element 2 and then square it and see what we get. Okay. So now it's going to be, second element is 17. So we'll put 17 in here. All right, so we'll do 17 minus 14.4 squared. Well, 17 minus 14.4, okay, let's go ahead and do that in the calculator. 17 minus 14.4 is 2.6. All right, so we're going to have 2.6 squared. Okay, so 2.6 squared is going to be 6.76. All right, so 6.76. So that's our second number, 6.76. You see, we're going to do that. What we're doing here, we're going to do it for every single number. We did it for 14. We just did it for 17. Now we have to do it for 12. Now, when we do it for 14, it's going to be this same number again. So we can just put this same number in, okay? Let's go ahead and do it for 12 now, okay? All right, let's erase a couple things here. Erase this. Whoops, I didn't mean to erase the whole thing. Let's go ahead. All right, so now we're going to do 12 minus 14.4, and let's see what that's going to be. 12 minus 14.4. We're just subtracting the mean from every single element in the set. That's negative 2.4. Okay, so we're going to wind up here with negative 2.4 close parenthesis, and then we have to square it. So we have parenthesis, negative. Now, anytime you square a negative, you've got to use the parentheses. Otherwise, it's not going to square the negative. So negative 2.4 squared, and that's going to be 5.76. Okay, so this is going to be 5.76. And so the next number is 5.76 plus. All right, now we have to do the same thing with 14, but we already did it with 14 once, so we know we're going to get the same number, which is 0.16. Now we only have one number left to do it with. We've got to do it with this 15 right here, okay? All right, so let's go ahead and erase this 12 out of here. And we'll erase this stuff out of here, and we'll get a new number over here. Okay. So 15 minus 14.4, which is pretty easy. That's 0.6, okay? All right, and so now we're going to do 0.6, or just 0.6 squared, and that winds up being 0.36. 0.36, okay? So our last number here is 0.36, okay? So that's 5 numbers all being added up. Why are we adding up 5 numbers? Because our formula says to go from 1 up to n. N is 5. So we're summing up terms that go from 1 up to 5. How do we get each of those terms? We do this thing. We do this, take the number minus the mean, take that value, and then square it. And that's what we did 5 times. So that's why we have 5 numbers. What's going to go on the bottom? Well, we already said 5 goes on the bottom because n goes on the bottom. All right, so 5. Now we're going to need the calculator. We're going to add up these 5 numbers. Okay. All right, so I'm going to bring this actually over here. You can see all the numbers. There we go. So we're going to do 0.16 plus 6.76 plus 5.76 plus 0.16 plus 0.36. And what we wind up with is 13.2. So this is 13.2, and then all we have to do is divide that by 5. So take our 13.2, bring this a little closer. All right, 13.2, we're going to hit divided by 5, and that gives us 2.64. 2.64. And so the variance of this data set, the variance squared of x sub I, is equal to 2.64. And now we want to know what is the standard deviation of the set x sub I. Well, now we just have to take the square root of 2.64. All right, so let's go back to the calculator and do the square root of 2.64, and that gives us 1.62. That's really hard to see. Let's see if I can pull up the full screen. There we go. It's easier to see. 1.6248. 1.6248. 1.6248. Okay, and that is the standard deviation of this data set. Okay, that's what you have to practice doing. That's what you have to be able to do. That's all we're doing this week in lesson 6.2, is we're just identifying the variance and the standard deviation. Really, standard deviation is so easy. All you're really doing is identifying the variance. And you may say, man, that's a really complicated formula. You're right, it is a complicated formula. But I promise you that if you did this about 10 times, it'd become a piece of cake to you. You'd recognize it and you'd be really good at it. That's why I'm going to make you do it more than 10 times, okay? All right, let's do another example. Okay, here's another data set. We're going to call it y sub I, and here's your formula up here. I hope you've written the formula down somewhere in your notes, okay? And what we're going to do, the first thing you need to do is identify the n. We got to identify the sample size, which is 1, 2, 3, 4, 5. Okay, all right, that's good. And then I'm trying to keep the sample sizes small because this is complicated. Okay, so I'm keeping the sample sizes small. 5 is as large as I'm going to go on these. Okay. All right. So in order to do this, we first need the mean. Okay, of y sub I. Okay. And so to find that, we need to sum up all the elements from 1 up to 5 of y sub I, and then divide by 5. Okay. And those elements are 3 plus 2 plus 5 plus 6 plus 5. And we're going to divide all that by 5. Okay? So 3 plus 2 is 5, plus 5 is 10, plus 6, 16, plus 5 is 21. So we're going to do 21 divided by 5. You can use a calculator if you want, but I happen to know that this is 4.2. So our mean is 4.2. So now to identify the variance of y sub I, we're going to do go from I equals 1. We're going to do a sum up to 5 of each y sub I minus 4.2, square each one of those, and then divide the whole thing by 5. Okay? All right, so let's do the first one. Our first one is 3. Our first, y sub 1 is 3. We're going to subtract 4.2, okay? And then we're going to square that, whatever that is. Well, 3 minus 4.2 is negative 1.2. We're going to square that, okay? And that's going to give us, let's go to the calculator here, parenthesis, negative 1.2, close, square, equals 1.44. Okay, so this is going to be 1.44. And so our first term here is going to be 1.44 plus, so now we're going to do the y2 is 2, and 2 minus 4.2 is negative 2.2. So let's go ahead and square negative 2.2, parenthesis, negative 2.2, close parenthesis, square. That gives us 4.84. All right, so this is 4.84. So our next one is 4.84. Okay, good. Plus. All right, now let's do it with 5 minus 4.2, which is going to be 0.8. Let's see what 0.8 squared is. So 0.8 squared, and that gives us 0.64. All right, so our next one is 0.64. Okay, 0.64 plus. Now we're going to do the same thing with number 6. All right, put the number 6 right here. Well, 6 minus 4.2 we know is 1.8. I feel like we did 1.8 already. Was that 1.44? Maybe not. Let's do 1.8 squared. No, it's 3.24. Okay, so now this is going to be 3.24. Remember that this formula right here, this piece that we keep doing over and over, it comes right out of the formula. It's the each individual number, okay, minus whatever the mean is, which we did separately. We got 4.2, and then you just take the difference and square it, okay? So we're doing that for each number. So 3.24 here, okay? And then the last number is 5, which we already did two numbers ago. So we're just going to repeat that number, which is 0.64. So plus 0.64. We're going to add these 5 numbers up and then divide by 5. Okay? And so let's go ahead and add these all up. Okay, when we add up all these numbers, we get 10.8. All right, so this is going to be 10.8 divided by 5. And when we do 10.8 divided by 5, we get 2.16. Okay, so this is going to be 2.16. And so the variance of this data set, y sub I, is 2.16. Now if we want to know what is the standard deviation of the data set, we just have to do the square root of 2.16. We can do that in, we'll do this, we'll do the square root of the answer, and that gives us 1.4697. Note we're making this 6 a 7 because of this 9 right here. 669 is very close to 70. So this 69 basically becomes a 70, and we get 4697, 1.4697. So 1.46697. Okay, and so we've identified the variance and the standard deviation of this data set right here. Okay, I think we should do probably just one more example. Okay, here's our last data set. These numbers are a little bit bigger. It looks like our n is 1, 2, 3, 4, 5. It's 5 again. That's okay. And so n is 5. And now, in order to be able to identify the variance, we are going to need the mean of these 5 numbers. And so we know that the mean, the population mean of A sub I is going to be determined by summing up all of the numbers from 1 up to 5 of all of the elements of the data set A sub I. Then we're going to divide by 5 because because n is equal to 5. So this is going to be 36 plus 45 plus 39 plus 39 plus 42 divided by 5. Okay, let's go over the numworks and get this sum. All right, so here are the 5 numbers. We add them up, we get 201. And then we're going to divide that by 5, and we get 40.2. 201 over 5. And we wind up with 40.2, okay? And so now, to do sigma squared of A sub I, we want to go from I equals 1 up to 5 of each A sub I element, but minus the mean, which is 40.2, and then each one, after subtracting, will be squared. We'll add all 5 of those numbers up, and then we'll divide by 5, okay? And so the first one is going to be 36 minus 40.2 squared, okay, which is going to be equal to negative 4.2 squared, which winds up being 17.64. And you can check that in a calculator. 17.64 plus, now we're going to do the same thing with 45. Minus 40.2, which is 4.8. Then when we square that, we're going to get 23.04. So this will be 23.04. And now we're going to do the same thing with 39. All right, so now we're going to do 39 minus 40.2, and we get negative 1.2. And then when we square that, we get 1.44. And so then this is going to be plus 1.44 plus, then the next one is also 39, so we're going to have another 1.44, and we only have one left to get. Now we're going to plug in 42. Okay, so let's plug in 42. 42 minus 40.2 is 1.8. 1.8 squared is 3.24. So our last number here is going to be 3.24. And then we'll add that whole thing up, divide by 5. All right, let's do that in the NumWorks calculator. Okay, so you can see here we've added up all 5 of these numbers. We hit equals, and we get 46.8. And then divide that by 5, and we get 9.36. 46.8, 9.36. 46.8 over 5 becomes 9.36. Okay, and so then the variance of these 5 numbers of this data set, a sub I, is 9.36. And if we want the standard deviation of a sub I, all we have to do is the square root of 9.36. Okay, so the square root of 9.36, that's just the square root of this answer, and it becomes 3.0594. 3.0594. 0594. Okay? All right, that's it. I know this is pretty tough. I promise you, if you practice it a lot, you're going to get pretty good at it, and you might even develop some shortcuts for yourself. Okay? I will see you next in lesson 6.3.